guys, welcome back and nice to see everyone again. And for today's video, we'll discuss about topic 1.2 structural formula. In this subtopic, we have a few learning outcomes that we are going to look into. The first learning outcome is definitely knowing what is actually structural formula. The second, we are going to learn and draw the condensed, expanded and also skeletal structure. We're also going to classify the carbon and hydrogen into their classes. So first and foremost, what is actually structural formula? Structural formula is a chemical formula that shows how the atoms in the molecule are bonded to each other. And we have three types of structural formula. Structural formula can be written in the form of expanded structure, condensed structure, or skeletal structure. A very simple of expanded structure, condensed structure, and skeletal structure is something like this. Expanded means we are going to show everything. Don't worry, we are going to look into in detail. So for example, I have my propane. My propane is a CH3. And in the expanded structure, you are going to show everything, all the atom and all the bond. While in the condensed structure later on, you are going to hide all the single bond between carbon and hydrogen. For example, for the propane, your condensed structure will look something like this. CH3, CH2, CH3. That is how a condensed structure looks like. While for the skeletal structure, it will look something like this. So that is the propane expanded structure, propane condensed structure, and the propane in the form of skeletal structure. So what makes these three different structural formula different? So let's look into detail of each and every one of them. So first and foremost, expanded structure. What is actually expanded structure? Expanded structure means you are going to show every atom and also the type of covalent bond in the molecule. In the other words, you are going to show everything, all the atom and all the bond in the molecule. But bear that in mind, we are only showing all the atom and bond. It does not need to represent the shape of the molecule. It means that it's not needed to be in the correct shape like tetrahedral, trigonal bipyramidal, and so on. We only need to show the type of atom and also the type of bond. That's it. And the example of expanded structure could look something like this. You show all the atom and also the bond in this structure. Same when you have a double bond, as well as when you have a double bond with oxygen and also different functional group. So you're going to show all the atom and also all the bond. You're going to expand everything. Well, for the condensed structure, what is meant by condensed? You're going to pack everything up. But what are we packing up? What are we going to condense them? We are going to condense, we are going to hide the single bond between the carbon and also carbon and hydrogen. We are going to hide the single bond between carbon and carbon and hydrogen. For example, if that is my ethane, I have a CH3 in the form of expanded. If I'm going to condense this structure, then it will be CH3, CH3. That is meant by condense. Alright? Condense means we are going to hide this single bond and also single bond between the carbon and hydrogen. We are going to hide them and we are going to simplify them in the form of CH3, CH3. That is condensed structure. Next, we are going to show the double and triple bond. If there is a double or triple bond, we are going to show it. We only hide the single bond between carbon and carbon and hydrogen. Last but not least, if I have two or more similar group bonded to the same atom and branches, and the number of the atom or branches will be the subscript. For example, I have a CH3. So I started off with a CH3 and I draw it in the form of expanded so that you can clearly see it. And then this carbon over here holding 2Cl. And then I have another CH3 in the form of expanded. And I'm going to write the contents of this molecule. How can I write the contents of this molecule? Simple. The first carbon holding 3 hydrogen, so we condense them up, CH3. Okay. And then the second carbon, look at the second carbon. The second carbon holding Cl, Cl. So you have 2 Cl over here on the same carbon. The same atom or branches that are going to write in the bracket. So you have a carbon holding 2 Cl. Cl, 2. So subscript 2. And then you have a CH3. That is the way that we write the condensed. Can you see it? CH3, carbon, bracket, Cl, bracket 2, CH3. That is the atom or branches that are located in the same atom. And that is the condensed. Let's look at more example for the condensed structure. So for this one, how can I write the condensed structure? That is pretty simple. This carbon holding 1, 2, 3. So I have a CH3. This carbon holding 2 hydrogens. So we pack them up. We are going to condense them up. CH2. Over here, this carbon holding 2 hydrogen as well. So condense them up. You have CH2. This carbon, last but not least, holding 3 hydrogen. Condense them. Bear that in mind, in the condensed structure, we are going to hide the single bond between the carbon and also the hydrogen. Let's look at the second example. So I have a double bond over here. We know that in the condensed structure, we will only hide the carbon-carbon single bond and also the carbon-hydrogen single bond. We are going to show all the double bond. So this carbon over here, holding 2 hydrogen, I will have CH2. This carbon, double bond with a CH. So double bond with a CH. Can you see that? Single bond, we are going to hide this single bond. Alright, we are going to hide this single bond. So you have CH. And look at this carbon. This carbon is bonded with CH3, 1, CH3, 2. So you have 2 group of atoms that are bonded to the same carbon. And this is your CH3. This also is your CH3. So how can I write it? Simple. Bracket, CH3, bracket, 2. And that is the condensed structure for your second example. Okay? Simple. Just remember, in the condensed structure, we are going to hide the carbon-carbon single bond and the carbon-hydrogen single bond, except in the ring. When you're having a ring, we cannot hide the carbon-carbon single bond in the ring. That is the only place that you're going to show the carbon-carbon single bond in a condensed structure. So for this one, your structure will look something like this. CH for the top carbon, bracket with Cl. This carbon, CH, bracket Cl. This carbon is bonded to, on the left side, you have a CH. So it's bonded to a CH. Double bond with another CH. Can you see that? So you have a double bond with another CH. Okay? And then this carbon, alright, this carbon over here is single bond with a C double bond O. So it's bonded single bond with a C double bond O. See that? Alright, that is your C double bond O. Last but not least, the last carbon holding a CH2 over here. Can you see the CH2? So this one bonded to the CH2 and complete the ring. So that is the condensed structure of a ring. Okay? You are going to condense everything up except the ring, because you cannot condense the ring anymore other than this. This is the simplest way that you can condense a ring. Bear that in mind, you can show the double bond and also triple bond. Okay, simple. Next, let's look into skeletal structure. What is actually skeletal structure? Skeletal structure is going to hide the carbon atom and the hydrogen atom. Read the sentence carefully. We are not hiding the bond, guys. We are hiding the carbon and hydrogen atom. You remember just now I give you a skeletal structure of propane like this? So we are hiding the carbon and hydrogen atom. Why I say I'm hiding the carbon and hydrogen atom? Because every corner of this, and this represent carbon. So it's actually a carbon bonded to a carbon, bonded to a carbon. Can you see that? Alright, every single dot over here, every single corner of the line is actually a carbon. So we are hiding the hydrogen. And how do I know how many hydrogen the carbon having? Bear that in mind, every standard carbon having 4 bonds. So carbon must have 4 bonds. And over here, the first carbon only having 1 bond. So there is 3 more bonds. It's not enough with 3 more bonds. And the 3 more bonds will automatically be hydrogen. See that? And the center carbon over here already having 2 bonds. 1, 2. So this carbon not having enough of 2 bonds. So the 2 will be hydrogen. See that? Alright. So the bond that is not enough will automatically be hydrogen. And how many is not enough? Every carbon must hold 4 bonds. Alright. So the last carbon over here holding 3 hydrogen. And that is your expanded structure of this skeletal structure. Okay, bear that in mind. Skeletal structure is not hiding the bond. We are hiding the carbon and hydrogen. But the functional groups such as OH, NH2, COOH, what else? Alright, all the functional group must be shown, even though the hydrogen is there. Bear that in mind, we are only going to hide the hydrogen that are bonded to the carbon. We are only going to hide the hydrogen that are bonded to the carbon. The hydrogen bonded to the functional group like this must be shown. Alright? The bond will be represented by lines, as I say. So one line over here is actually 2 carbon. 1 carbon, 2 carbon. Alright? So every corner over here is a 3 carbon. Can you see that? If you have another one, 1, 2, 3, 4. Let's say. How many you have? How many carbon you are having? 1, 2, 3, 4, 5. So you have 5 carbon over here. That is how we read skeletal structure. Carbon atoms are at every corner of the line. Like I said just now, that is how we calculate the carbon atom. It works exactly like in the ring. You are having a ring like this. So how many carbon is in this ring? It's a 6 carbon ring. It's a cyclohexane because you have 6 corner over here. And every corner, every end of the line represent a carbon. Can you see that? Okay. So I have over here, how many carbon am I having? Obviously 1, 2, 3, 4. I'm having 4 carbon over here. Let's draw the expanded of this skeletal structure. I have a 4 carbon like this. Okay. And how many hydrogen is the carbon holding? Like I said, every carbon must have 4 bonds. So the bonds that are not enough are the hydrogens. So this carbon, the first carbon on the left, will be having 3 hydrogen. The second carbon from the left will be having 2 hydrogen. The third carbon from the left will be having another 2 hydrogen. The last carbon over here will be having 3 hydrogen. Okay. So that is the way that we are hiding the carbon and hydrogen in the skeletal structure. Let's do a few examples of skeletal structure. We are going to learn to understand this skeletal structure first before you draw. Okay, after you understand, then you should be able to draw very easily. So this is a corner, 1 carbon. That is my first carbon. Double bond to a carbon. So double bond to a carbon. That is the way that I expand it. And then this carbon bonded to another carbon single bond. So bonded, single bond to a carbon. This carbon bonded to a carbon over here. So coming down, there is a carbon. And another one on the right. So this carbon also bonded another one on the right. Okay? So let's count. Do we have 5 carbon in the skeletal structure? 1, 2, 3, 4, 5. So over here, we have 5 carbon as well. Okay, make sure the arrangement is correct. Now we are going to put in the hydrogen. The first carbon on the left having a double bond. Double bond means you already take up 2 bonds. And 1 carbon only can have 4 bonds. Now I already have a double bond, which is 2 bonds. So this carbon on the left will have another 2 bonds bonded with hydrogen. Simple. The second carbon over here already holding a double bond, which is 2 bonds, and also a single bond. So 4 bonds minus 3, so you left 1. So this carbon only hold 1 hydrogen. This middle carbon, the third carbon from the left, you are holding, alright, 1 single bond and another single bond. And another single bond down here. So how many bonds can this carbon hold? 1 more. Hydrogen. Can you see that? The last 2 carbon at the bottom and on the right, both of the carbon only holding 1 single bond. 1 single bond over here. So this carbon will be having another 3 bonds, and all the 3 bonds will be hydrogen. And that is the way that we calculate how many hydrogen the carbon is holding. The very basic concept that you need to know is every carbon must hold 4 bonds. Remember that. Every carbon must hold 4 bonds. Remember. Another example for skeletal structure. Let's see how do we expand this. Okay. Can you see in the skeletal structure that I have OH over here? We are not hiding the H because it doesn't belong to the carbon. It belongs to the O. So let's expand this structure. I started off from the left of this carbon. So I have a carbon over here. This carbon. Single bond to a carbon. Single bond to a carbon. Coming down, single bond to another carbon. Single bond to another carbon. And this carbon, guys, this carbon right now holding a Br. So draw the Br first. We are going to expand everything in the skeletal first. Okay. Moving up back to the carbon, this carbon right now, the third carbon bonded another single bond to another carbon. Single bond to another carbon. Alright. So this carbon right now, bonded single bond to this carbon. Single bond to this carbon. Okay. So how many carbon you have? 5. 1, 2, 3, 4, 5. The 5 carbon. We are not done yet because we still have oxygen. The last carbon is double bond to oxygen. Double bond to oxygen. Okay. And also single bond to the OH. Single bond to the OH. Alright, since it's in the form of expanded structure, I'm going to expand everything, all the bonds that you have in your structure. So, let's put in the hydrogen. Let's count from the left again. The carbon, the first carbon on the left holding a single bond only. So there is 3 more bonds available, and all the 3 bonds automatically will be filled out with hydrogen. Nothing other than hydrogen because there's nothing else in your skeletal structure. The second carbon over here already having 2 bonds. Alright, the second carbon already having 2 bonds. So, another 2 bonds with hydrogen. The third carbon from the left already holding 3 bonds. Single bond to the carbon, single bond to the carbon, single bond to the Br. So, there is only 1 more bond available for the hydrogen to make the carbon holding 4 bonds. The fourth carbon from the left, over here holding 2 single bonds, the single bond to the carbon, the single bond to the carbon. So it has 2 single bonds available attached with hydrogen. The last carbon last but not least, the last carbon that holding double bond O and single bond OH already have enough 4 bond. If you look at it, single bond, 1, 2, 3, 4. So this carbon already holding 4 bond, enough. There is no hydrogen attached to this carbon. And that is how we change the skeletal structure to your expanded structure. I hope at this moment you understand your skeletal structure already. Bear that in mind, in the skeletal structure, we are going to hide the carbon and also we are going to hide the hydrogen that attached to the carbon. Simple. Let's do a few examples. I have my expanded structure over here. We are going to change this expanded structure to the condensed and also to the skeletal. So let's see. My expanded structure starting with, from the left, this carbon holding hydrogen, hydrogen, hydrogen. So the condensed should start off with a CH3. Because in the condensed structure, we are going to hide the single bond. Alright, we are going to hide the single bond between the carbon hydrogen and also the carbon. So bear that in mind, C single bond H, single bond H, single bond H will become CH3. But we can show the double bond. So the C double bond O over here, we are going to show it. C double bond O. And then bonded single bond to a CH. Bonded single bond to a CH. Having a branch over here, the branch is NH. The branch over here is NH. And the NH also bonded with a CH3. So CH3. Can you see that? The branch over here is the entire NH and CH3. That is the branch. So you put it in the bracket. And then continue back to the chain. Is you're having a CH3 at the end of your expanded structure. So that is the condensed structure of your expanded structure. Simple. Alright. Next, we are going to change this expanded structure to your skeleton. So let's see. I started off with the first dot, which is a carbon. Alright, that is my first carbon. Bonded to a C double bond O. So this is my first carbon. This is my second carbon. This second carbon is bonded double bond O. Okay, so we are done with that. Continue to the third carbon. Continue to the third carbon. So the third carbon over here having a H. So we are going to hide the H. So ignore it. Single bond to a NH. So bear that in mind, we must show all the functional group. NH. Okay, so we are done with this. NH is bonded to a CH3. Bear that in mind, we cannot show the carbon and hydrogen. So that is the way that we are going to draw it. Okay, so we are done with that. The CH, that is my CH3 over here. Okay, that is actually the CH3. That is my CH3 over here. Alright, that is actually the CH3 down there. And then we continue back to the chain. The chain have another CH3. So you have another CH3. Okay, that is your another CH3. So let's check again, guys. That is my C first carbon. Second carbon, C double bond O. So second carbon, C double bond O. Third carbon, that is my third carbon. The third carbon coming down to a NH. So coming down to a NH. And this NH holding a CH3. So holding a CH3 over here. Okay. Bear that in mind, in the skeletal structure, you must hide the carbon atom and also the hydrogen atom that is bonded to a carbon. Okay. Last but not least, the CH3 over here. So that is the CH3. And that is your skeletal structure. Simple. We are only changing the way we are writing. There is no reaction. Therefore, the number of atom of the carbon atom, hydrogen atom, oxygen, or anything in there remain the same. Okay? Now the example, I give you the condensed structure. So we are going to expand the condensed structure and also going to draw the skeletal structure. Let's expand it first. The first one, CH3, simple. I have a carbon bonded to H, bonded to H, bonded to H. Another carbon is a CH2. So carbon bonded to H, bonded to H. Next, this carbon bonded to a CH. CH. One more bond is in the bracket. So the bracket Br is belong to this carbon because it's the branch Br. Next, we have CH2. So this carbon holding H, holding H. And the OH also belong to this carbon, but why it's not in the bracket? Because it's belong to the last carbon, so it's not needed to be in the bracket. When you expand it, the bond between the O and H also need to expand, because in the expanded structure, you are going to show all the bond that you have in your structure. And we are going to look at the skeletal structure, how to draw the skeletal structure. The first carbon bonded to the second carbon, like this. That is my first carbon, that is my second carbon. The third carbon holding a Br. Okay. And then the last carbon holding a OH. Okay. Let's check. The first carbon, CH3. The first carbon, CH3. The second carbon, that is my second carbon holding nothing else. Okay. The third carbon, CH, holding a Br down here. Holding a Br down here. Okay, can you see that? Last carbon, the last carbon, that is my last carbon. And this last carbon holding a OH. So the last carbon holding a OH. Skeletal structure. Simple, easy, easy. Last example before we move on to classification. So the last example I give you the skeletal. We are going to change this skeletal structure into condensed and also into expanded. And I always love to start with expanded. Okay, that is the easiest way. So we are going to expand one by one. Expand the first carbon first. That is my first carbon. So draw it first. That is the way that I expand. Look at it. I draw the carbon. Don't draw the hydrogen first. We'll put in the hydrogen as the last thing. So don't worry about the hydrogen. Draw the carbon first. First carbon. Second carbon. So single bond. Second carbon. The second carbon over here, guys. The second carbon over here. Bonded to NH2. Draw it. Bonded to NH2. Draw it. Done. The second carbon also bonded to a carbon. Bonded to a carbon. See that? Alright, that is my third carbon. Done. The third carbon also bonded to a carbon. Bonded to a carbon. Alright? And the last carbon just now, this last carbon is bonded to OH. So this last carbon is bonded to OH. See that? So I have put everything that I have in the skeletal structure into my expanded. Okay? And at this moment, your expanded structure obviously is not complete because the carbon have not enough 4 bond. So what are we going to do to make it complete? Calculate the bond, make sure the carbon have enough 4 bond. And those that are not enough will automatically be hydrogen. Simple. The first carbon over here. The carbon having only one single bond. Obviously, this carbon have another 3 bond. And that is the hydrogen. So the first carbon is actually a CH3. The second carbon over here having 3 bond already. 1, 2, 3. So there is one more bond. Hydrogen. See that? The third carbon having 1, 2 bond already. So 2 more bond. That is hydrogen. The next carbon over here also having 2 bonds already. 1, 2. So 2 more bonds, hydrogen. And that is your complete expanded structure. So don't put the hydrogen as your first thing. Hydrogen is always the last thing that you put in when you are changing from skeletal structure all the way to expanded. Hydrogen is always the last thing to make your structure complete. Okay? And we are going to change this into your condensed. Obviously, CH3. Easy. Second carbon, CH. Having a branch of NH2, guys. So what do we do when it's a branch? Bracket, NH2. Okay, close bracket. The third carbon, we are having a CH2. And the last carbon is a CH2 holding OH. Do we need to put the OH in bracket? No, because the OH is belong to the last carbon, is not needed to be in the bracket. And that is your condensed structure. Simple. Alright. And that is all about your expanded structure, your condensed structure, and your skeletal structure. I just want to remind you one thing over here. There is no reaction. So the number of atom, the number of carbon atom, hydrogen, nitrogen, oxygen, or whatsoever is not changing. You're only drawing them in a different way. Okay? Bear in mind, there is no reaction. Okay? Next, we are moving into classification of carbon. Easiest thing ever. There is only one requirement. You only can classify a sp3 carbon. The sp3 carbon means a carbon with 4 single bonds. The carbon must be holding 4 single bonds if you want to classify it. If the carbon is holding a double bond or triple bond, we cannot classify the carbon. For example, if the carbon is a C double bond C or the carbon is C double bond O, we cannot classify the carbon in that. The only carbon that we can classify is the carbon must be holding 4 single bond. Okay? So we have 4 different classes of carbon. The first one is your primary carbon. We call this primary carbon. What is meant by primary carbon? Primary carbon over here means the carbon is holding 1 carbon. It's bonded to only 1 carbon. That is your primary carbon. Okay? Another one, we have a secondary carbon. And the way that we write it is a 2 knot. Secondary carbon over here, vice versa, like your primary. Primary means bonded to 1 carbon. Secondary means this carbon is bonded to 2 carbon. Alright, when the carbon is bonded to 2 carbon, that is your secondary. Next, you have your tertiary carbon. Tertiary carbon, 3 knot. 3 knot means what? Means that your carbon is bonded with 3 carbon. And when the carbon is bonded singly bond to 3 carbon, that is your tertiary carbon. Last but not least, you have your quaternary carbon. Alright? The quaternary carbon, 4 knot means what? Obviously, the carbon is bonded to 4 single bond carbon. And that will be your quaternary carbon. Alright? Let's look at some example. If I have a structure like this, we are going to classify all the carbon in here. And obviously, if you look at it, all the carbon can be classified because all the carbon over here having 4 single bond. 1, 2, 3, 4. So we can classify this carbon. And this carbon will be what class of carbon? It will be primary because in this 4 bond, only 1 bond is bonded to carbon. So this carbon is a primary carbon. Okay? Second carbon over here. This carbon, we also can classify this carbon because it's having 4 single bond. 1, 2, 3, 4. And if you look at the 4 single bond, all the 4 single bond is bonded to carbon. Carbon, 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 carbon. So that is your quaternary carbon. Alright, next, this carbon over here. Alright, this carbon over here also having 4 single bond, 3, 4. And this carbon is a primary carbon because it's only bonded to one carbon. The rest is hydrogen. Next one, this guy also a primary carbon because this guy right now holding 4 single bond, but only one single bond is bonded to carbon. So this carbon also primary carbon. Next, I have this carbon. What class will this carbon be? This carbon having 4 single bond, 1, 2, 3, 4, and there is 2 bond that is bonded to carbon. Secondary carbon. Last but not least, this carbon will be a primary carbon. So that is the way that we classify carbon. Alright? When you expand it or when you are good enough, you can classify it without expanding it. So let's see how to classify the carbon when it's not expanded structure. Okay, so I have a structure over here. So we are going to classify all the carbon if we can. There is 2 carbon that we cannot classify in this structure. Alright, this carbon and also this carbon. Why we cannot classify these 2 carbon? Because they are not holding 4 single bond. They are holding double bond. So when the carbon holding double bond, we cannot classify them. And when you cannot classify them, we only ignore them. Don't put 0. Do nothing. Alright, do nothing. When we say we cannot classify them, just write nothing on it. Leave it. Okay, leave it just like that. So we are going to start off with this carbon. So what would this carbon be? This carbon will be a tertiary carbon because it's bonded to 1, 2, 3 carbon. The carbon up here, what would this carbon be? This carbon would be a secondary carbon because it's bonded to 1 carbon, bonded to 2 carbon. Okay? This last carbon over here is a primary because this carbon is only bonded to 1 carbon. Okay, it's only bonded to 1 carbon. Next, the carbon over here. The carbon over here is a secondary carbon because it's bonded to 1 carbon, 2 carbon. Secondary. Okay? Bear in mind, this is your skeletal structure. If you don't understand where is the 4 single bond, this one actually holding hydrogen, hydrogen. To make it complete 4 bond, that is actually holding a hydrogen. Okay? I can expand that for you first. For example, this carbon over here also holding 1 hydrogen. This carbon over here holding 2 hydrogen. Remember skeletal structure, we are going to hide the hydrogen. Okay, so there is actually 4 single bond. So what would be the class of this carbon? This carbon will be tertiary because it's bonded to 3 carbon. 1, 2, 3. Okay. Next over here is a secondary carbon because it's bonded to 1 carbon, 2 carbon. Alright, makes sense over here? Next, we are moving on. This carbon right now will be what class of carbon? Let's see. 1, 2. Secondary. The top carbon over here, this carbon will be a primary because it's only bonded to 1 carbon. The center carbon over here, guys, the center carbon over here, pretty obvious. That is your quaternary carbon. 1, 2, 3, 4. Okay? And the last 2 carbon that we haven't classified, that is your primary. That is also your primary. Okay? That is how we classify carbon even though we did not expand it. You can look at the bond. Alright? You can just look at the bond. You can just look at the neighbor is whether carbon or not carbon. Simple? So carbon, you can have primary, secondary, tertiary, and quaternary. And the way that I answer right now is when the question say label or when the question say indicate. When the question say label or indicate, then we are going to label or indicate in the structure straight away. That is how we label and indicate. But when the question asking for number of primary carbon, secondary carbon, tertiary carbon, and quaternary carbon, when the question asking for the number, we are not going to stop at labeling and indicate. We are going to calculate the total of primary, secondary, tertiary, and quaternary carbon in the structure. So for the primary carbon, we are going to calculate how many primary carbon we have over here. Primary, 1, 2, 3, 4. So for the primary carbon, you have 4 carbon. Move on to the secondary carbon. So secondary carbon, 1, 2, 3, 4. So for the secondary carbon, the total that you have is 4. Moving on to your tertiary carbon. How many tertiary carbon you have? You have 1 tertiary carbon, 2 tertiary carbon. So you have 2 tertiary carbon over here. Last but not least, quaternary carbon. You only have 1 quaternary carbon. Okay? So 1. The way that you answer the question, be very careful with the keywords that the question gives to you. When the question say label and indicate, that is the answer. When the question say calculate the number of primary, secondary, tertiary, and quaternary carbon, this should be the answer when the question asks you to calculate the number. Okay? So read the question carefully. You need to give a different type of answer. Next, we are going to look at classification of hydrogen. If classification of carbon is easy, classification of hydrogen is nothing. It's even easier. The class of hydrogen depends on the carbon it attached. In the other words, if the hydrogen is attached to a primary carbon, then it will become a primary hydrogen. Simple. Alright? If the hydrogen sitting with a primary carbon, primary hydrogen. If the hydrogen sitting with a secondary carbon, secondary hydrogen. So primary hydrogen over here means that the hydrogen is sitting with a primary carbon. So this carbon right now is a primary carbon because it's sitting with only 1 carbon. So these 3 hydrogen will automatically be primary hydrogen. Secondary hydrogen over here means that the carbon is a secondary carbon. Secondary carbon because the carbon is bonded to 2 carbon. And the hydrogen that bonded to this secondary carbon will be secondary hydrogen. Simple. Last but not least, tertiary hydrogen. Okay? Tertiary hydrogen over here means that the carbon is a tertiary carbon right now. And this tertiary carbon having 1 hydrogen, and that hydrogen will be classified as tertiary hydrogen. That's it. Simple. So just very quickly to go through some example. Alright, let me classify that for you first. That is my primary carbon. That is my quaternary carbon. That is my primary carbon. Primary, secondary, primary. Okay? So what hydrogen would this be? This hydrogen will be a primary hydrogen because it's a primary carbon. Simple. If the hydrogen is bonded to a primary carbon, then it will be a primary hydrogen. So very, very simple. Alright? You basically need to classify the carbon, then you will know what class of hydrogen it is. So this carbon, also the same, is still your primary hydrogen. That is still your primary hydrogen. And that is your secondary hydrogen because it's a secondary carbon. So that is your secondary hydrogen. This carbon is a primary, so you are still again having a lot of primary hydrogen over here. Simple. Alright? Easy. Next example. The same structure. So let me classify that for you first. Over here, tertiary. Over here, secondary. Over here, secondary. Over here, tertiary. This one, secondary. This one, primary. It's a secondary. This carbon is a quaternary. Primary, primary, primary. Before I continue, let me expand it first. Bear in mind, this carbon is actually having another hydrogen. Don't forget it. This carbon having another 2 hydrogen because it's a skeletal structure. We are hiding the H. This carbon having another hydrogen to complete the 4 bond. So this carbon having another hydrogen, another 2 hydrogen to complete the 4 bond. this carbon also actually having another hydrogen to complete the 4 bond. Alright, but can we classify the hydrogen over here? We cannot classify this hydrogen because we don't classify this carbon. So we cannot classify the hydrogen either. Okay, so what class will this hydrogen be? This hydrogen will be secondary. This hydrogen will be a tertiary hydrogen. Secondary hydrogen over here. Secondary hydrogen over here. Tertiary hydrogen. All of these 2 hydrogen will be secondary. Or both of these hydrogen will be primary because they are bonded to a primary carbon. Both of these hydrogen will be a secondary because it's bonded to secondary carbon. Or these 3, and these 3 will be a primary hydrogen because all of them are bonded to a primary carbon. So all the hydrogen over here will be a primary hydrogen. Simple. Alright. So I hope you can classify the hydrogen and carbon easily at this moment. But bear that in mind, before you classify the carbon and hydrogen, make sure you know how to draw the structural formula in the expanded form, in the condensed form, and also in the skeletal form. Bear that in mind, the expanded structure, the skeletal structure, and the condensed structure having some rules and regulation on how to write them. So make sure you understand that clearly. Feel free to drop me a question in the comment below, and if you think this video helps you, give me a like for this video and hit the subscribe button. I'll see you in the next video. Thank you for watching.